And so like I said, like as I kind of get these parts, make sure it's all set for us to go over, we'll talk about SQL, which is what module, it's our first lesson for module 2. So module 2, section 9. So module 2 is focused around data engineering. So we'll go over a whole bunch of different parts. SQL, tomorrow will be object-oriented programming. And then we'll go into, I believe, APIs, JSON, XML formats, which are basically just ways to encapsulate data and pass it back and forth. So we'll talk about that on Thursday and into Friday. And then we'll go into next week too for more data engineering. We'll see SQL again. I think we even talk a little bit of NoSQL as well. We'll go right into it. So I'll go ahead and start sharing my screen. If I can get to it. There we go. Oh. All right, cool. So you guys should see table of contents right there. And of course, after I ask you guys disappear. Where did you guys go? Nope, that's not right. So I have too many windows and too many screens, apparently. There you guys are. Okay, cool. So you guys can all see table of contents, right? Awesome. So, okay, cool. So just kind of going through our lesson structure. This will, right now, it's not uploaded into the repo that I normally keep everything in. Know that that will eventually, I'll eventually put that in there. So from this recording and everything like that. But at least right now, it's not up, so just kind of be aware. But basically, know that we're going to have some, outcomes, basically like things that you should be able to have out of this lesson itself. So I should be able to build a function to perform queries. That's the hope that you will be able to do. Also, you'll be able to execute query using multiple joins. So we're going to talk about like, a join. We're going to introduce that a little bit. We'll go more in detail as well, like what joins are and all this stuff. But I'm going to do a very basic kind of intro to joins. I know the curriculum has a lot more information on it, but the goal is that we can do multiple joins for this. We'll see if we get to that part. And some objectives that we have going forward. So we're actually going to try to use, we are going to use a data frame from a query based in SQLite3. So we'll talk a little bit about how we do this exactly. We'll talk about like the bad ways to do it, which can be a huge issue. But then we'll also compare and contrast using DataFrame, using the results from a query, like where that comes in. We'll talk about, we'll actually be able to write a single join query and then write multiple join queries. Cool. Okay. So, and then our outline, basically, I'm going to skip this over a little bit because I feel, unless you guys have any specific questions about SQL, I think most people are kind of like at that, mid beginner level right now of like what this is. So we'll introduce all those things. We'll introduce SQL, and then going forward, me and Jeff will take turns basically doing instruction where we're showing you how to connect to a SQLite database, discussion on reading SQL databases, more complex queries, you basically using joins and selecting certain columns. And then we'll practice some queries, as well as maybe hopefully be able to get to a point where we can complete a join query, as well as multiple joins, and then we'll wrap it all up together. So our hope is to get through these two parts, but not necessarily, like we might not necessarily get through that, but at least what's it called? This notebook will be available for you guys to try out those parts if you don't reach them, okay? Cool. So introduction to SQL. So I actually have another notebook to share here. And this one right now is actually within the Jupyter, in the repo on GitHub right now. But anyway, so introduction to SQL. And note that I pronounce it SQL, not SQL. Both are technically correct. I tend to hear SQL more for more modern usage, but note that you'll hear SQL, SQL go back and forth. It's basically the same thing, just depends who you talk to. Okay, but basically, first, it starts off with like, what is a database? So I'm sure you guys have all like, who's ever heard the term database? Like, hopefully you guys have at this point. Yeah, so as data scientists, prospective data scientists, you hopefully have heard the word database, right? But if you haven't known, basically a database is a table of data. It's a bunch of tables of data. It's a bunch of information. It's usually structurally formatted. You can kind of compare it to like how you think of like a CSV or an Excel file. And you can kind of think of those like as a database being a collection of different Excel files or a collection of CSV files and such, okay? So in a database itself, we have something called a schema. You'll hear me use this a lot. This is also right here is an ERD, which I cannot for the life of me ever remember what ERD actually stands for. But I'll usually call it a schema. I've heard a lot of people call it schema because basically your schema is how your different tables, you can think of like your different Excel files, your different like CSV files. They're obviously more complicated than that because they're compressed in certain ways. But if you think of them like these different tables are connected together and how they relate to each other. So this is why, because they're related to each other, they're called relational databases because computer scientists are super creative like that, right? So the point is basically is that these tables can all relate to each other. So they have similar parts where you can get different information. Usually the schema, this ERD, is given to you by the business. Hopefully they have something. I've gone to some businesses that don't have this available, or they're outdated and stuff like that. So just know that's kind of reality. Sometimes you have to kind of explore yourself. But the idea here is with these kind of forms like this, you'll see something very similar like to these stuff a lot of times. It's to help you navigate through the database. So you can see here, basically, each of these rectangles are essentially our, what's it called? Our different tables. So this product lines table, these products tables, these order details, and this is actually the database we'll be using for our little, what's it called? Our instruction coming up. So these parts right here in product lines, product line, text description, HTML description, image, those things are the different, like essentially you can think of like the different columns within like, you know, your table. And so basically each row is a single entry. So the idea is hopefully every entry, right, every row will have some attribute or some item under product line, under text description, HTML description, image. And the way these can relate to each other is basically using these similar codes. So for example, a product line, let's say it's like toothpaste or something like that. I don't know. But let's say toothpaste right here. The way it connects to product lines to products is that you'd actually have another attribute here, or the same thing. In this case, product line is the same from, product line from in products is the same as product line in product lines. So that's their connection. That's how they relate together. And you can even see that some of them will actually relate to each other. So for example, reports to under employees, well, that's actually another employee they're reporting to. So this reports to might actually be an employee number in the sense that it's reporting back to another element in this table. And so this is how all these tables are connected together. And we'll see a little bit this will be really important when we do joins. So this is how we'll actually connect them together. So you'll also see as well as, and every ERD does it a little bit differently. But you'll see especially like these little stars, asterisks right here. This case is likely actually representing something called a primary key. And so there are ways to like create a schema without primary keys, but for the most part, you will see every table have at least a primary key. It's usually required for most enterprise levels. So a primary key basically is the thing that identifies that item in the table. So for example, in product lines, the thing that identifies it as product lines is product line. For employees, employee number, it looks like, is the thing that identifies here. Same thing for office codes for offices. So you can kind of see, you know, how this like identifies. Note that you can also have multiple multiple columns to represent your primary key. So in this case, order details, order number, and product code together will be unique, which hopefully makes sense. Is that in order details, basically what this is going to be is like if you have an order, like if you order multiple things like from Amazon or wherever you're shopping online, you might have, you know, product one, you know, bought 2 of them, and product 2, you bought like, you know, 12 of them. Well, each of those have specific order details. So your order number is specific, but then also the product code. So you might have multiple order numbers, but order number and the product code together will be unique within this table. Okay, so that's an important part to see. So know that your primary key tends to be can be either one thing or multiple things. In practice, at least what I've seen in enterprise, people try not to use these where multiple order detail or different primary keys are, or sorry, multiple columns are used as one primary key. Usually I'll see things like a serial point, and basically it's just a made up number that increases up and up and up. And that way they make sure it's always unique. So sometimes you'll see some things like serial be used. Note that in this database, we're not using any serial part because it doesn't have to use it, but you might see that a lot in enterprise level databases. Okay, and then last part, I just put a little side note, foreign key. I always think this is kind of funny because it's like a foreign key basically is just a reference to another table. So like if I have something, for example, product line and this products, this is a foreign key to product line's primary key. Makes sense. So it's kind of like, oh, a foreign key is referring to a foreign table. Okay. Any questions on this specific in relationship or how these keys are kind of used to navigate through? Okay. Yeah, go ahead, Rebecca. Or do you have a question, Rebecca? I can't hear you if you're talking. Oh, let's see if I can unmute you.
Oh, shit.
No, you're fine.
Okay, sorry. I'm unmuted. Hello?
Yes.
Okay. I think you can hear me, right?
Mhm.
Oh, it says, yeah, my computer's confused. What are those little symbols between like each table? Because they're, I've seen them before, but they always seem to be a little different from
Yeah,
different, you know, documentations.
yeah. Depending on your ERD and how it's drawn out, these are actually like one to many, many to one to one. To be quite honest, I personally don't pay attention too much to it because like I more like explore the database itself. They are supposed to represent, basically one to many, many to one. We're actually going to skip over that part today, but it is talked about in the curriculum. Basically, it's saying, how many product keys or how many like elements in this table can relate to elements in here. So like, let's say, for example, a product or a product line can have multiple products. So let's say toothpaste is your product line. I don't even know what product lines
Yeah.
are, but like,
I mean, I
you
just
can have
want to
like
know
Colgate. Like
the
you can
little
have,
symbols, man. Yeah. I mean, I
yeah.
got to the one, you know, I also know,
Yeah. And
seen it
I'll tell
before.
you, this
I just
comes
don't know what
directly
those
from,
little things. Yeah.
yeah. I'll go ahead and refer you back directly to the curriculum because they go through the full detail. To be quite honest, like off the top of my memory, I won't be able to remember it. That's just
I
reality,
didn't think
unfortunately.
okay, I didn't think it was in there. The little, actually, like the little circle with the
Mhm.
arrow or this, you know, the two little hash marks or whatever. I
Yeah.
didn't think
And those are
okay.
representing one to many and stuff like that. And I know there it should be in the curriculum as well. But of course, you can always like you can look up specifically towards your database. And every schema or every ERD has a different way of displaying it as well. But you'll kind of see it as you go through. Okay, good question though. All right, so I'll move on to the next part. What is SQL itself? So that's a database. That's what we're going to be using. SQL itself is basically a way to communicate with the database. It's actually a command language where basically what you're doing is you're sending, hey, here's my what I want. Here, server, take my stuff, process it through, and give me back what I asked for. And so what's really nice is that it's very versatile. Is that you don't actually have to like put in specific parts of like you don't have to worry too much about how it's going to be executed. It can be executed on that side, and you have this server deal with it. There's a little subtlety of why that is. But what's also nice is that it's from the 1970s, which might sound like, oh, that's old school or whatever, like but because it's so it's well traveled in the tech community and stuff like that, it's used for a lot of things. The terminology and the structure of the language really it's relatively consistent across multiple parts. So you'll see SQL used a lot. Through there, and it's pretty consistent in that way. Even with no SQL, there's a lot of interfaces with using SQL itself. Okay, so who uses SQL? Basically, anyone who's using like a data analyst, anyone who's dealing with data, you're probably going to have to use SQL at some point to get data from the server itself. Many businesses, it's like I said, 1970s. That means a lot of businesses already have SQL servers in place. People are familiar with them. They've been there for years and kind of deal. So it's kind of like just an easy thing for people to keep using. So you'll see like I guarantee you'll be using SQL in any data analyst, data science, anything dealing with data, you will see SQL at some point for sure. Okay. And so that kind of ends up like, why use SQL? It's like, well, it's super common, right? Like if everyone is using it, you probably should know how to use it. I think there's every once in a while, I'll see like a survey go out to data scientists, like, what's the tool you use the most? And like, it's almost overwhelming saying, I use SQL like every day, like because you're getting data all the time. All right. But one nice thing, and this is a little subtlety for computer science, is it's kind of fast. What happens is that you don't have to process the data on your computer. You can have it processed on the server's computer. And you can do some really kind of cool things. But basically, your SQL is kind of like, the way I kind of imagine this is you get a piece of paper, and we'll talk about this in APIs, but you get a piece of paper, you write down, I want this, and you hand it off to, like your little messenger person. And your messenger person takes it off to the server and says, like this person wants this stuff. And the server goes, okay, let me aggregate that and get what you need, does that, and then sends it over, which is a lot more efficient than saying, oh, here's all of the data, which could be like gigabytes large. Here's all the data, sort it out yourself. SQL allows you basically to get the server to do it for you, which can be super nice. Okay. That was a quick introduction to SQL, kind of like what it is. Basically, you can think of SQL as being the command language to talk to the server and get data from a database. Okay, cool. All right, so we'll move on to the next part, which will be for Jeff. And Jeff, did you just want to grab control of it?
Yeah.
Okay.
All right, am I in control?
Should be.
Okay, cool. Yeah, I can click around. All right, yeah, thanks for having me here. Really excited to be here. Like Victor said, I'm another instructor, and we're just kind of co-teaching. So I think Victor might eventually go the opposite way and teach one of my cohorts. Yeah, like Victor said, databases are really, really important. I used to work as a data scientist at a railroad. Whenever I interacted with data, the data was never stored in CSVs. So it's very convenient that it's in CSVs, but there's a lot of problems with that. And databases make it a little safer, and a lot of other great reasons. So getting comfortable with SQL is very important. My workflow is always, we had these big SQL tables. You query the SQL table, get the data that you want, then put it into like a DataFrame if you're going to do some sort of analysis, and then build your machine learning algorithm or so. But step one is SQL. So let's kind of go through this. In this course, we're teaching SQLite. SQLite is a self-contained serverless database. So what does that mean? Can I make a new cell? So in this particular case, our data set is running locally. It's just here locally. It's not on a server. And kind of what Victor was saying, that most databases that you interact with will be on a server, and they're not going to be there locally. Main reason for that is these databases are usually huge. Like you can't fit them locally on your computer. So you're doing a query and you just want this date range or this columns. I used to have to do this report that when I first started as a data scientist, I was not very good at SQL, and this query would take over 90 minutes to run. And then if I got a little bit more efficient with it, it took about like 40 minutes. So it's still like huge. It's going to take a huge amount of time, but like 90 minutes to 40 minutes is like a big difference. So SQLite, it's just going to be kind of what I'm going to say is chilling on your kind of in your directory. The pro of SQLite is that it's not on a server, so it's really easy to set up. You don't have to connect to a server. You don't have to have a server running on the background of your computer. Next, you're going to be connecting to our SQLite database. To connect to a SQLite database, first we need to do this part. We have to have two parts, a connection and then a cursor. The cursor is what's going to allow you to actually interact with that database. So there always have to have two parts when you're connecting to a SQLite database, the connection and the cursor. And one of the first things that I always do when I'm interacting with a database for the first time, and Victor kind of talked about this, is a database is a collection of tables. So think of it like exactly like Victor said, a bunch of CSVs, a bunch of Excel files. You'll want to look at what the tables are, because that ERD or schema file, I'm going to be honest, in my experience, most of the time it's not up to date. So like it'll say like you have all these tables, but they're named wrong, or they're something's always kind of it seems the data engineering team usually has a lot on their plate, so it's mainly just working on like the tables and not really focusing on the ERD document. So taking a look at what the tables are is really important. And with this line right here, this will get you the different table names. And if you see, it looks like, yeah, it's a tuple. So we just grab our first element. Yeah, so the first element is a tuple, and with a list of tuples, you can use list comprehension and just grab that first element from each tuple, and then now you have a list of all the tables, and that's what we do next, right here. So this is kind of a nice process to follow, so that way you know all your table names, and then you can kind of go back to the ERD and say, okay, I thought there was a order related table, and maybe there was order details, or maybe I always just do it as kind of a sanity check, because if you think like a SQL table is named something and it's named something different, you're just going to get an error that says it doesn't exist. And like if you like misspell it, or it's spelled a different way, or there's not an S, it's not plural, it can be very difficult to figure out what the problem is if you don't know what the actual table's name is. And then, yeah, just coming along, here's our first SQL statement. So we're doing select star. Star is a shortcut for all columns. So you could list out all the columns, or you could just do this little shortcut right here, and that will grab all the columns for you. And so I want to grab all the columns from the employees table. And then to run it in SQLite, I do cursor.execute with that query, and then do .fetch all. And what I'm doing here, I'm just grabbing the first two elements and displaying that. Typically, you will not want to do this query right here, because like I said earlier, these tables are usually too large to fit on your computer. So if you grab every column, this is grab every column, every row from the employees. I usually do like a limit. This is similar to like a .head in Pandas, where you're just getting the first 5 rows. So if we remove that. And so it's a little safer. So like if you do this on some tables, it could take all day to run, or it could eventually just crash your computer. So I always start out with just usually just doing like a limit, just grabbing first 15 rows or something, just to get like a little bit of an understanding of the data. Any questions or anything? Well, I think I will pass it back to Victor. He's going to go over some more complex problems.
Yeah, cool.
I
Thanks,
have
Jeff.
a question.
Yeah.
So, like doing the labs that we've been doing, I find myself scrolling like up and down a lot. And it's like a great thing, like that you just showed, to get the table names. But do people like typically print out what the tables look like, so you're not like, I don't know, going back and forth everywhere? I guess I find like it's not very convenient to like look into things when I'm like scrolling up and down.
I gotcha. I guess
Especially because you have to like remember the names, like you were saying.
Yeah. Usually the databases are large enough that have enough tables that I can't remember all the names. I'm kind of trying to think of my workflow. I usually had a couple screens so I could interact, see all the table names on one, and then. But what I find I do most is I do really common. I know I have a Monday report where I have to get this exact same SQL query. So once I've typed that out once, I'll save that as a Python script, so I can just call that Python script and run that every Monday. It's a lot of like the SQL queries, you're just running kind of over, repetitive, where you just have to build it once, and it's kind of complicated when you're building it the first time, but then it's just, okay, I got my data for Monday, now I need to see what happened with these trains over the last week.
Okay, gotcha. Thank you.
No problem.
Yeah, and just kind of going off what Jeff had said, like definitely like reusing queries and stuff like that, whether it's like the full query itself, or whether it's like, I've done plenty of times where I've had a query and I am like getting parts of it or referencing it, and I'm like saying, okay, I need this part, I need to get this to get all the person's contact information and put this into here if it's a new kind of query or new report. That's really common. Like people save their little bits of queries and stuff like that, and so that way you can kind of we're not going to show it here, but you can do something called subqueries, and you can kind of build up a query bigger and bigger and bigger. The largest query I've ever built was probably something like 250 lines of like 3 or 4 subqueries. Ridiculously, like huge amount. It honestly, it's not my favorite thing to do, but man, that thing ran so well. Like it was like Jeff was saying, like going from 90 minutes to 40 minutes. Like I got my thing down from originally like an hour down to like a minute and a half, and I was just so proud of that. But that happens a lot because you're trying to it's hard to keep all of it together. So like Jeff said, usually having it like on a side, like you'll see a lot of people, like the more screens they have, just the easier for them to organize. And I had the same thing, like literally have the table off to the side so I can reference it. Unfortunately, there's not like, I don't know of any better way other than just reusing the stuff or having it referenced like on the other side. Yeah, but anyway, good question though, Lauren, about like how to do that workflow. So I'll kind of go more now into a little bit more. So we kind of seen like really, like this is kind of like a really basic query. We actually kind of snuck in one right above here with Jeff, basically selecting all the tables and stuff. So this is also a SQL query. One thing to note, kind of going through, if you've seen the labs and stuff like that and the way we're writing it and the way I'll write it, you can actually, white space doesn't matter in SQL. You can put as much white space, new lines and stuff as you want, and it'll run perfectly fine. The biggest thing is making sure they're not like touching together and stuff like that and using the proper terms and stuff. Okay, so you'll see me write it a little bit different. So basically, like, you know, every time we want to query, it's like we could write this whole query out and like write it out and like then execute the whole thing. And you can kind of see like this is kind of a tedious process in my opinion, right? It's kind of like, okay, like we have this part, we're basically using that cursor to say, hey, like the way I can think of the cursor is like it's like my messenger person. It's like, hey, like where are you in the database? And it says, or execute this query for me, and then getting this fetch all. And like, I don't know about you guys, but I get lazy. Like I'm like typing things over and over again. But you can see that what we do is like select star from offices, we get the whole query. I can do cursor to execute basically that query. So the cursor basically is that connection to my server, which in this case just my computer, but executes that query. And then from that query, we can get the results. We can either fetch one. So you saw Jeff use fetch all. You can also do like fetch one. There's a couple other things you can do. So for example, if I run this guy right here, we'll have our result. And oh, I should actually probably print out the result. So if I do a result, you can see here, there's the first result for offices. Similarly, if I did like fetch all, you will see all the offices. So if I run this now, you'll see, oh, that's the results. Sorry, there we go. So you can see here, so all the results down here. So this is a way you can kind of go through, but you know, I don't know about you guys, this is not pretty. And then the worst is like, this is on display. If I actually do print right here, it's just all like one gobbledygook. And I'm just like, ugh, that's awful. No one wants to do that. For the record, again, display, that's what this is doing right here. It's just display nice and easy. So we kind of want to avoid this, doing this over and over. And one thing to note is that we kind of skipped over, it's like, these are all supposed to be columns, but like, what column is this? It's just the number one. This is clearly a city. This is probably a phone number, but like, what are these values? We can actually use the cursor to say, hey, give me the description, list of descriptions. And the way basically SQLite will display this, it's not super pretty as well. There's some internal reasons why there's a bunch of like this tuple. I call it tuple instead of tuple, but like, you know, the same thing. But you can see here, it's this list of different values, and these represent the different columns. So you can see here, this is supposed to be the office code. Next one is the city, then the phone, address line 1, address line 2, and so on. So this is kind of a pain, like when you think about like having to deal with this data. So what we could do is like, we could do these parts and then get the data in the dictionary or in the list, make it however we want, or we can make a function for this. So what's nice about the function is like, since we're going to do the same thing over and over again, we're basically going to use the same cursor, put in a different query. We can say, all right, do this results for me. So result is equal to cursor.execute query fetch all. So this is basically what Jeff had shown in the past couple, queries. And say, okay, cool. Like we know this is going to give us all the results, just like this over here, a list of tuples or tuples. Okay. And basically we can take that part. It's like, well, okay, we know what the results are going to be. And I can go ahead and say, well, that's just going to be all of those results. And I can actually add in the description. Once I know what the description is going to look like, it's basically that first element in here is going to be the description. So I use a little list comprehension right here. And actually, to be honest, I probably could take this part off too. This is technically a tuple or tuple list comprehension. So you can also do it that way. But if you are familiar, that's perfectly fine too. So just know, it's like, okay, we're just going to get the first element in each of this long list of things. So we'll get office code, city, phone, all this stuff into a nice tuple. We'll combine them together and we'll get one full result. So if I run this now, I have this nice function called SQL with columns. Look at that doc string right there. Okay, it's not the best doc string, but it exists, okay, which is an important part in my opinion. And then we have our results. So now I can do the same thing, but if I want to get all these results like over here from select star from offices, I can just do the same thing, but let's say employees this time. And so I can do this result and I have this nice results. And now if I go ahead and I'm actually going to make a new cell underneath here so I can show you what the full results are. So remember, basically it's just running that function. And now you can see here, I have the first one is basically all of the, what's it called? All of the column names. And then afterwards are all the results of the actual like from the database itself. So I can actually print this out. It's like, well, let me show the description. You can see here, here's the descriptions, and then here are all the items. Okay, I'm going through. So that's a little bit better. It's at least one thing together, but we can do one step better. So obviously we've been using pandas for the past, month, right? Kind of be nice to use pandas with all this stuff rather than a bunch of lists. So I can also make another function, right? And so in this case, basically what I'm going to do is I'm going to make a data frame from scratch here from the results. So basically I'm actually just going to call my query from above, or my function definition from above, get the results. Okay, so that's basically just a long list. First one's being descriptions, and the next one after are different results. And basically I can say, okay, well, column names will just be the results, or the first part, which is descriptions. So that's what this is right here. And then my data will just be everything else. Basically, everything except for the first one, everything onward will just be my data. So that will actually return a data frame. So this is how you can make a data frame from scratch. So that's pretty nice. And so now if I do this, if I do my df equals to SQL df, I just pass in my same query. And now I have a beautiful, beautiful data frame. And I can do all my nice pandas things and everything like that. Okay, so this is pretty sweet. Like we can actually take a query. We can get all this information. Remember, SQLite3 wasn't built in mind of like pandas directly. It's just built in with, oh, using Python to get data. So they're building it out of lists. But since we want a data frame, we can do it this way. I will tell you right now, there is another way to do this. I personally try not to do it this way because I won't even show it to you because I feel it's a bad habit. But there might be some issues when you try to load the full results directly into a data frame. So let me ask you guys, what might be some issues, pros and cons of loading a full results from a query? So basically loading directly into a data frame, like essentially doing this without ever checking the results. Anyone got an idea where this might go wrong, or the pros or cons? I see some kind of puzzled faces being, So let me ask you guys. We kind of talked about like, Jeff was talking about being safe, right? And like when he talks about being safe with these queries and stuff like that, and limiting. I think I heard someone start talking.
Oh, yeah, it just blows up, right? I mean, they could get a, 100. You could, start going and never finish loading because it's just too large.
Yeah, it could be too much, right? So one thing is that the SQL query can actually run really quickly, but the data it needs to pass over is a huge amount, and basically you're just passing it directly into a pandas data frame. So one issue with pandas is that, what can be a potential issue is that you're loading it all directly into memory, essentially. So like basically, like if you have, like, let's say, imagine you ask queries like, hey, give me everything, right? And like you didn't put a limit like Jeff just talked about. And it's like, give me everything. And it's like, it gives you, 12 gigabytes of data. One's actually getting that data onto your computer. But then two, it's just going to load it directly into a data frame. Maybe your computer can't handle that much space from pandas and stuff like that. So that can be a huge issue on their dealing with that. So that's why I like to say, play it safe first. Like do a little test query and say, does this work out well? Okay, cool. And if I know it's going to be the same thing, I can load it into a data frame to manipulate it better. Any pros for like why you would want to just load it into a data frame? Like I kind of mentioned a little bit, but those kind of obvious ones. Why do you want your data into a data frame? Or why do we use data frames in general?
It's easier to like look at and come up with findings.
Yeah, easier to look at, easier to like manipulate, right? So those are ways we can basically like, we're familiar with pandas. We can just take a data, get into a pandas format, and it's basically like you read it from a CSV file, and it's nice and easy. This again, like why I like to like make these functions first, but I like to have this intermediary SQL with columns, is that like it allows me to do a little bit more basics first, and I can do quick, length and stuff like this that's native to Python without having to worry about, memory space for like a pandas data frame. I can also, with like the SQL with columns, I can also, if I did it from the query, I can actually fetch one. So I can do like SQL fetch one or something like that, and then it returns me one result, and I can see if that's the result I want, versus like getting all the results at once can be really useful. Okay, so there's kind of things you can consider, especially as you start getting into what we call like big data, where basically data that can't be processed by one computer. In that case, there's other ways you can kind of get around this. You can do things like chunking and like using other distributed systems, but we'll talk about that much further into the course. Okay, so now I got this nice little function, and I know for this database that it's relatively small, so I'm just going to keep using this function. But just always be aware of like, you know, what you're using and what that's going to do while you're doing stuff. So here's my next kind of query right here. And so before we just been selecting star, which is basically select all the columns, right? So we can actually select very specific columns. So you see here, I have employee number, last name, first name, extension, and so on. If I want just basically very specific parts, I want just the first name, last name, job title, and then email, I can do a few things. So one is I can actually say, all right, give me the first name, okay, from employees. So you can think like select first name from employees, okay, so that table, so I'll get the first name. But you'll notice I do this as first name right here. And this is something called an alias. And so what this allows me to do is actually rename my column right here. So you'll notice my first name, last name is just the name of that column specifically. This will actually return it as a specific name, which is really useful. This can also be really useful as subqueries and stuff like that. You can rename things however you want. And then note that I just put a comma at the end here to separate them out, saying I'm selecting all these parts. Note that I put like extra tabs and stuff like this. This is completely optional. It's just a white space. I could have gotten rid of all the tabs. I could have put it all in one line. I just mostly do this for readability, and it makes it nice and easy for me to organize my like, you know, query and everything like that. Okay, but basically these are all the columns I want. Select these columns, and this is from the tables, and we'll actually see, we'll use multiple tables in a second. So when I run this now, this will actually look like first name, last name, position, email. So note that job title now is no longer there, but it's the same values here, and you can see it's a little ordered in this way. What's also nice is that you might have noticed is that last name, first name comes first. I can actually put in different orders. I can put first name first, last name first, you know, I can mix things around. I can choose specific parts. I can decide not to use an alias. One thing that eventually you might say, like, wait, can I do like star and then this part? Unfortunately, no. SQL doesn't let you do that. It's just like, I think in this case, I can do it because it's one table, but as you get more general, this won't work, unfortunately. So just kind of know is that for the most part is that you'll end up just selecting specific elements from here. If you're doing, if you want to select specific element or columns, you're going to have to specify each time. Okay. Any questions on this guy right here? No, pretty good. And just to double check, we've all seen this like 3 quotation marks before. Cool. So that's how you can write multiple lines as well. So it makes it a little bit easier for us to read this way. Okay, so our next part is going to be actually using multiple tables. So right now we've only been looking at just one table at times, this from employees table. Okay, we can actually use multiple tables. So let's say I have a couple tables here. Let's say order details. So I have this order details table, and we can see there's order number, product code, quantity order, and I also have another table here called products. And we'll look at products now, and you can see here there's a product code, and then it tells me what each product is with some information about that product. So it would be really nice to be able to combine this part, saying, okay, well, let's say I want to see what in this specific order detail, what this product code, like this is nice, but I would like to know what this product actually is, right? Like what this product name is. So we want to combine those together. So we can actually, so one way you could do this if you weren't familiar with using SQL, you could actually load these as 2 separate data frames, then combine the data frames together, and then have a resulting data frame, because that's something we can do, concatenate together. However, again, we have the issue of saying, well, that's a lot of space. So like if you get all the results from products, all the results from order details, you fit those all into memory, and those can both be very large, where we can say, hey, server, do this for me. Like, don't make my computer do it. You do it for me. And that's why we actually use SQL to kind of combine these things together. So the way we can combine them is, let's say we just say select star. Okay, select star just means give me all the columns. For everything you're going to give me, just give me all the columns. I'm not going to care which ones. And I'm going to join, basically, I'm going to combine these, what's it called? These tables together. So the first table I have is order details. So remember, that's a little short table right here. And note that the one thing in common here is product code. Okay, so that actually means that's the way I'm going to connect them together. And if I look at my ERD, you would actually see there's a little primary key, maybe foreign code or key and everything like that. But I know these are the similar parts. So I can say, okay, join, which is going to be something called an inner join. So I won't go into full detail of like left join, inner join, outer join. That goes into the curriculum. We can maybe talk about that at a future time. But just know for the most part is that if you just put join here instead of just inner join, this will by default make an inner join in here. The most common ones you'll see are basically inner joins and left joins. I think that's pretty, like, I'm trying to think of all the cases where I'll see any other kind of join, and really that's it. I might have seen an outer join like once in like enterprise at all. Right joins, If you guys gone through the curriculum, basically it's a left join but flipped over, so I never see right joins because they're just left joins. But just kind of give you some details. But anyway, this is an inner join. So basically it's going to combine, and basically it's only going to keep the parts that are crossed over. So in this case, I'll take my order details, and I'm going to join the products table. And then now when I say join, it needs to know, hey, how am I going to join these together? How do I know what belongs to what? And this is where you can use a keyword. And I think Jeff shows a different way of doing it as well, because there's a couple ways you can do it. But one way I do it is just using on. So like join products on, and then order details dot product code. So this is saying, hey, get the product code from order details. So that specific column is equal to products dot product code right here. And so this is basically saying what column. Now, the reason why I'm doing this way too is probably out of habit, is that I like being very verbose, because sometimes these columns, even though they do match up in this case, they don't always match up. I've had a lot of times where you would have serial and target serial, for example, in a lot of enterprise uses. And so it's useful to kind of like specify what exactly column you're using. Okay, so what this will do is basically, all right, it takes order details, and then it will join basically the intersection where they're both in the product code from order details and the product code from products is both in those parts. It'll combine them together and get all the columns. So if we see this now, we should see all the stuff from order detail. So you can see here, if you look closely up above, it stops at order line number, and you can see order line number. So it gets all of those parts, and then it combines all of the columns from products. And you can see here, these product codes should match up, which they do, and it will give you now the product line and everything like that, and all the information, which is nice now. Now we have all this information. However, this might be a little too much information than we really need to have. So what if we wanted just specific columns and stuff like that? Well, we can do that as well. We can actually say, hey, just give me these specific columns from this combined big table, okay? And then we can also do some things like renaming, these parts with aliases. We can also do some extra thing, which I'll show you at the bottom here. So this right here is just some code what we'll run down here. Basically, we can add custom names. So we can say, okay, order number, product name, we'll rename it as order, product, code, quantity, price per unit. Note that I put order in quotations. The reason why is because certain keywords in SQL, if it sees order is actually a keyword, same thing with select. If I put select there or something that has a keyword, it will basically give me trouble, say, hey, I don't know what you're talking about. So this is basically avoiding that issue. Now, the next thing you probably notice is this OD and P. This is actually coming from aliases from my from table. So this is kind of confusing when you first start, because like, wait, why do I have it named up here when it's down here? Basically, the way SQL works, it runs off this first and says, what's in my from tables, looks at that, and then it'll look at select. So what happens here is I'm actually renaming my tables as OD and then products as P. So basically this way, instead of rewriting out order details as, or like order details dot order number, blah, 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 blah. Like it takes a lot of time and I'm lazy. So I just basically made it really short. So this is a really common thing that you'll see. Technically, you'll see it not used as too. It's technically will still work. I think the curriculum might even use it that way. Again, I like being verbose because I like readability. Even if it takes me a couple extra seconds to type AS, I'm okay with that. But know that you technically don't need AS there, but it's a little clearer to read. And then from here, you can already see we use the same thing. Order details as OD, join products as P, and basically on od.product name or product code equals p.product code. So this is the same code as above. I just renamed the tables. And the only new part here is I'm selecting specific columns and I'm ordering a certain way. And then I can actually, let's see here. Yeah, I can actually get those parts. So now if I run this guy, you will see I get this nice small little table where I have the order, the product, the code, the quantity, price per unit, and then I actually write a total here. So this total, which I think, oh, it's right here. You can see here, you can actually do some quick math as well. So in this case, I actually did, okay, well, I know this is an integer, or integer, and I know this is actually, I'm sorry, this is an integer, and this is a float right here. I can actually combine these together and say, okay, this price each times quantity ordered, and give that as a total. So you can actually do some math on there. And that's nice because then I don't have to actually do that on my computer. Like imagine if you have like 100,000, 1 million rows and having to do that on your own computer. Your computer can do it, but sometimes it's better just to get the server to do it. Like make them do all the work, right? Versus your own computer. And that's where this is kind of useful. And there's some other methods you can do as well. I just wanted to show you a quick one that could be useful. Okay, so this is kind of like combining a whole bunch. And just look from all this stuff is that we now are combining multiple tables. We can order the different elements, stuff like that. And we can even do some math in here if we really wanted to. Okay. Any questions before I pass it back to Jeff on this guy?
I have like maybe like 4 or 5 more lessons left for this section. Does it go through how to like create the function that you went through earlier within the material?
Yeah, you're talking about this like function to make like a data frame and stuff like that. Yeah, there's definitely some detail on that stuff, and they might do it slightly different than the way I've done it. I think it's pretty similar. I think I either copied it or I copied close to it. That way it's not too unfamiliar, but same idea.
Cool, yeah, because right now they're just doing it like right under the coding each time. Data frame, but not creating it.
Yeah, this way I don't have to keep doing that over and over again, right? So.
Okay, thank you.
Cool. All right, and then other question.
Yeah, it's just, I mean, I guess you don't have to put the semicolon every time. That would, I mean, is that kind of like optional? I don't know. There's usually a semicolon right for the beginning, at the end, I mean, and then also, I guess the capitals for the selects and the froms don't really matter, right?
Yeah, the capitals in lower, like, so basically white space and capitalization doesn't really matter in SQL. There are some weird cases where it does matter. One thing you can notice that I put capitals here and it'll actually print out with those capitals as well. I have come across some weird systems, for example, like the thing is because SQL is not actually the programming language, it's a command language. It's like, here's what you should do. You can get in some weird cases of like, I had, for example, I could only run the system. I couldn't use limit directly on my query. I had like that Jeff showed like limit, like 10. I had to like specifically specify within the code editor. Is weird stuff. So sometimes you'll see some kind of weird stuff, but for the most part, you can say you can ignore white space, you can ignore capitalization, semicolons. It's probably best to put a semicolon to say this is the end of your statement. Like that's something that I tend not to do out of bad habits. So don't copy my bad habits, right? The reason why is because you can have multiple queries as well. So you can actually have multiple queries with multiple, and that tells us, say, hey, stop the query here and then go to the next one. So, but if it's only one query, you technically can just leave it out. Cool. All right, good questions. Cool. So, all right. So this kind of leads us into some walkthrough practice, which I'll pass back to Jeff to start us off then, and he'll lead you through those parts.
All right, didn't unmute myself. And let me request control. Thanks, Victor. Yeah, I think the best way to like really get good at SQL is just kind of go through some of these queries. Do I have control? Okay, yeah, perfect. So in this case, we want to come up, our output wants to be, we want our output to be this table right here. So we want customer name, we want the customer phone number, we want the customer state, we want the order date. And looking at here, we need the customer table and the order table. And I'm gonna steal Victor's really nice function because it is very nice. And what I'm gonna do is first, I'm just gonna grab just a couple rows from each of those tables just so I can kind of get a feel for what all the different columns are in that table. So I'll select star from, and I want to, first I want to look at the customers table, from customers. All right, so this table right here, this will have the customer name, which I need. It has the customer phone number, and it has the customer state. And I'm guessing order date is from the orders table, but we should double check just to make sure and not just assume. SQLDF, and I'm just going to do this exact same thing. Select star from the orders. All right, so there is a, where is it? Order date, there is an order date. So these are the two tables. I've identified all the columns that I want. And also something I'll want to kind of look at is what is the common column? What do I want to do my join on? And It looks like, yeah, there's a customer number in both of them. So that's what I will do my join on. So that's what I look at first, all the columns that I need, and then what's the common column that I can do a join on. So I'm just going to make a new variable where I'm going to put all this query in. So I want to grab, first I want to grab the customer name, and I know right away I'm going to use an alias for the customers table of C. So I'm going to do C dot customer name. I'm going to grab the phone number. So again, this is from the customer table, so I'm going to use the same alias, the C phone. I'm going to be grabbing the state as well, so C.state. And then I also want to grab the order date from the orders table, and I'm going to use the alias of O for order date. So O.order date from the customers table as C. And I want to do a join statement with the orders table. So join orders as O. And then, if I remember correctly, yeah, you used on, right, Victor? And on's a really good thing to use. I just want to show another way to do this. This only works if the column you want to join on, the column names are exactly the same. You can use using, and I'm going to be joining on the customer number. So like Victor was saying, if this was named slightly different and you wanted to do a join on these two columns, you couldn't use using. But since the columns are exactly the same named, you can use using. So customer number. And did I lose access? Oh, okay. And then I'm going to take this query and I'm going to put it in that nice function that Victor wrote. And customer name, phone number, state, order date. Customer name, phone number, state, and order date. Any questions or anything? Nice. Do you feel like you could do that? All right, well, cool, awesome. And I think, Victor, you have the next one.
Yeah, sure. Thanks, Jeff. Yeah, so like you guys saw, like that's kind of how you would build up to like getting to combine different tables together and selecting specific columns. So I'll kind of go to the second one then. We have a few minutes, like 3 minutes. I think it'll be enough time for me to show you quickly since we've already seen one. So you can see here in this case, I want to create a query that results a table with every customer number for an employee along with the employee name and number. So it looks like I have the employee names, first name, last name, employee number, and then customer number. So we want to see what this is. So just like Jeff was showing, like this is kind of like how you would end up, like say, let me just explore a little bit. And this is where like I personally like try to do a little quick queries and stuff like that just to kind of see what goes on. So I'll do select, and then I'll do, let's see here, I'll just do star just to see what everything's in that customer table. I'll do from customers. And there we go. So you can see here is that I'm looking for customer number. It's like, there it is, right? So that's what we want in here. We have first name, last name, employee number, and then customer number. And there's going to be something that's going to connect between employee and customer number, right? So I could go ahead and make a new cell right here so I can check this out. And I'll go ahead and use my function again, which again, this is where like you'll write certain functions that just work really well for your workflow. So I'll do select star from employees. And note that I'm not being consistent here too, which is perfectly fine. So you can see here is that I have our employee number, last name, first name, extension, job title. So we want to see how we can connect these two together. Oops, there we go. Okay, and we can see sales rep, employee number. Okay, so we can see here that's what we're talking about, who made the sale, what employee talked to them. So we want to connect this number with this employee. And just like Jeff had mentioned, you can use using if it's the same number or same column, but in this case it's different. So I'll actually have to connect these different together, or I'll have to use a different way. So I'm going to go ahead and just write this part right here, first name, last name, employee number, customer number, and then employee number, customer number. So I'm just going to use this guy right here. So I'm going to do select, and I actually like to use my from statement sometimes first. So I'll actually do employees. So employees join, what was it, customers. And I'll just put as E and then as C. And then I'll actually join this using the on E dot was employee number. And then what would I do here? I would do the customer number or customer, but it's going to be sales rep employee number. So I'm just going to copy that. Okay, so I have this part, and then I'm going to have select E dot first name, or I'm assuming this is a customer's name. Maybe not. No, it is an employee name. So I'll do employee first name, and then we'll have employee last name, and then what do we have next? We have, does anyone remember? Employee number. So employee number and then customer number. So E dot employee number. And then I'll have, let's see here, our C dot customer. Oops. Okay, so there we go. So that should look good, right? And let's go ahead and run this. Oh, and I'm actually going to change this out. So I'm going to go use my handy dandy function. So SQL to df, and then we'll use our query head, and hopefully that looks good. So yeah, there we go. Okay, so you can kind of see quickly building through, just making your different parts. And we're kind of over time, but any last questions on like how this would work on this guy? No, sound pretty good. I know Jeff had another one to go through next, but at least this notebook will be available for you guys. You can check it out and everything like that. Let me see here. Yeah. Actually, I do have to go to a project assessment right now. So actually, Jeff, do you actually want to lead through maybe a joint session with the students, or?
Yeah, I can. If anyone wants to stay, I can do that last problem.
I can't stay, but I will look at it online.
Okay. All right. I'm gonna have to head out, but you're in good hands. And thank you, Jeff, for helping out with our study group and everything like that. So I will see you all soon, at least tomorrow. Okay. Take care. Oh, how do I leave? I just realized, Jeff, I can't leave because I'm sharing my screen with you.
Okay.
No, let me.
Yeah, maybe we could like just send it out as like a Slack exercise, maybe.
Yeah,
I think that's a good idea.
Fine.
We'll do that. All right.
Okay. All right.
All right, everyone. Well, I'll see you again. Thank you, Jeff.
All right. Nah, see ya.
Bye.